ಗುಡ್ ಈವ್ನಿಂಗ್. ಆಲ್ರೆಡಿ ನಾವೇನು ಮಾಡಿದ್ದೀವಪ್ಪ ಅಂದರೆ ಮೆಟಲ್ಸ್ ಮತ್ತು ನಾನ್ ಮೆಟಲ್ಸ್ಗೆ ಸಂಬಂಧಪಟ್ಟಂತೆ 1 ಮಾರ್ಕ್ ಕ್ವಶನ್ಸು ಮತ್ತು 2 ಮಾರ್ಕ್ ಕ್ವಶನ್ಸನ್ನು ಪಾರ್ಟ್ 1 ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ದೀವಿ. ಆಮೇಲೆ ಪಾರ್ಟ್ 2 ಅಲ್ಲಿ 3 ಮಾರ್ಕ್ ಕ್ವಶನ್ಸು ಮತ್ತು 4 ಮಾರ್ಕ್ಸ್ ಕ್ವಶನ್ಸನ್ನು ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ದೀವಿ. ಹಾಗಾದರೆ ಇದು ಪಾರ್ಟ್ 3 ಮೆಟಲ್ಸು ಮತ್ತು ನಾನ್ ಮೆಟಲ್ಸ್ಗೆ ಸಂಬಂಧಪಟ್ಟಂತೆ ಗಿವ್ ರೀಸನ್ಸ್ನ ನೋಡೋಣ. ನಿಮ್ಮ ಎಕ್ಸಾಮ್ ಪರ್ಪಸ್, ಹೌದಾ? ಒಂಥರ ಆಡಿಯೋ ನೋಟ್ಸ್ ಅಂತ ಹೇಳಿದ್ದೀನಿ. ಇಟ್ಸ್ ಹೆಲ್ಪ್ಫುಲ್ ಟು ರೈಟ್ ಯುವರ್ ಫೇರ್ಸ್ ಆರ್ ಲಿಸನ್ ಒನ್ಸ್, ಹೌದಾ? ಒಂದ್ಸಲ ಕೇಳಿಬಿಡ್ಲಿಕ್ಕೆ, ಅಥವಾ ನಮ್ಗೆ ನೆನ್ಪುಳಿತಾ ಇಲ್ಲ ಪದೇ ಪದೇ ಕೇಳಿದಾಗ ನಮ್ಗೆ ನೆನ್ಪುಳಿತದ ಅನ್ನೋ ಅಂಥವ್ರಿಗೆ ಈ ವಿಡಿಯೋಗಳು ಹೆಲ್ಪ್ಫುಲ್ ಆಗಲಿ ಅನ್ನೋಂಥ ದೃಷ್ಟಿಯಿಂದ ಇದನ್ನೇನು ಮಾಡ್ತಾಯಿದ್ದೀನಿ ಅಂದರೆ ಮಾಡ್ತಾಯಿದ್ದೀನಿ. ಹಾಗಾದರೆ ಸ್ಟಾರ್ಟ್ ಮಾಡೋಣ. ಎಲೆಕ್ಟ್ರಿಕ್ ವೈರ್ ಈಸ್ ಕವರ್ಡ್ ವಿತ್ ಪಾಲಿವಿನೈಲ್ ಕ್ಲೋರೈಡ್, what rubber like a material, what it's a insulated material. Okay, why? Because to prevent electric shocks, ionic compound in solid state do not conduct electricity, where molten state good conductor of electricity. Because in solid state ionic compounds, they not dissociate, or they not liberate their ions. So solid state ion cannot move from one end to another end, so there is no flow of electricity. But in molten state, they are whatever the ionic compounds are there, they are dissociated, or they are dissolved in that water, and the ions move freely, and they travel from one end to another one. That's why they conduct electricity. Ionic compounds have high melting point and boiling point. A large amount of energy is required to break the strong interionic force, because interionic force, plus and minus, whatever the bond is there, ionic bond is there, it's the strongest one. To break this ionic bond, we require some more energy. That's why a large amount of energy required to break the strong interionic force. Next, ionic compounds are solid at room temperature. Due to strong force of attraction between positive and negative ions, ionic compounds are solid at room temperature. Potassium, sodium kept in kerosene, because potassium and sodium are vigorously react with the water and air. They catch a fire if they exposed to air, thus they are stored in a kerosene or oils. Aluminium oxide is called amphoteric oxide. Why? Aluminium oxide reacts with acidic and it reacts with the basic substances to give a salts and water. Okay, it behaves like acid also, it behaves like a acid also and base also. Okay, and reacting with the acids and base, what it gives water and salts. That's why it is amphoteric. Whatever the dual nature is there, that's called as a amphoteric. Acidic and basic nature is there, that's called as a amphoteric. Next, 7th one question. Aluminium is more reactive than iron, yet there is a less corrosion of aluminium compared to iron. Aluminium reacts with air, form a thin layer of oxide around it. Okay, and that thin layer acts as a protective layer and prevent the metal from further oxidation. But in iron case, the thin layer whatever the formed, it not stops the oxidation reaction. Reaction goes on continuing. That's why compared to iron and aluminium, okay, rusting is more in iron, rusting is less in aluminium. Why? Because it forms a thin protective layer of oxide. Next, chemical reaction doesn't take place when copper is added to iron sulfate, because copper is less reactive than iron. Okay, because we already studied copper reacts with iron reacts with the copper sulfate, and what it gives iron sulfate and copper. This is a displacement reaction. Here iron is more reactive than copper, but what we are doing here, we are doing reverse reaction. That's not possible. Hydrogen gas is not liberated when a metal reacts with a concentric nitric acid, because nitric acid is strong oxidizing agent. It's very important. Several times they asked in exam. It oxidizes the hydrogen produced water and itself induced any of the nitrogen oxide. It may be nitrous oxide, okay, or nitrogen monoxide and nitrogen dioxide. Iron particles turn brown when exposed to moist air. Iron reacts with the moist air to form iron oxide. It may be in Fe2O3 form, or it may be in the Fe3O4 form. Metals conduct electricity because they have a free electrons. They offer little resistance to the flow of current. For making gold ornaments, 22 karat gold is preferred other than a 24 karat gold. Why? Because pure karat 24 karat gold is very soft. We cannot able to prepare ornaments. That's why it is not suitable for making a jewelry. It is alloyed with copper to make it slightly hard. Okay, related to metals and non-metals, two diagrams are very important. Reaction of a metal with steam. Reaction of a metal with a steam, it's a very important diagram. In this one, what we take a Bunsen burner. Here metal piece is there, it's a metal sample. We took glass wool soaked with water. Whenever we start to heat a glass wool soaked in water, it forms a vapor. Vapor comes in contact with a metal sample and it reacts, and whatever the gas is formed, it start to move with the help of delivery tube, whatever it is fitted in cork. And the test tube is arranged in where stand. Okay, delivery tube is connected to another vessel. That vessel contains soap water, or very sorry, not soap water, but inverted test tube. And inverted test tube filled with the water. In that, bubbles are formed. Whatever the bubbles are formed, those bubbles are because of hydrogen gas. Okay, and this test tube also fitted with the stand. This is the apparatus arrangement of a reaction of metals with a steam. Then another diagram is there. Which one? Salt solution. Salt solution is a good conductor of electricity. Testing of a conductivity of salt solution. Here, see, battery is there. Then a bulb to test the conductivity. To test the conductivity, bulb is there. Switch is there. Beaker is there. We took a two graphite rods. One is anode, another one is cathode. And we took a salt solution here. And we carry the experiment. If a bulb glows, means salt solution is a good conductor of electricity. If bulb is not glowing, then whatever the solution we took, it's not good conductor of electricity. This is the experiment. Then in previous questions from SSLC board April 2019 related to metals and non-metals, they asked some questions. We have to discuss those. First of all, give reason. Ionic compounds in solid state do not conduct electricity, whereas in molten state they are good conductor of electricity. This is one question. And another one question is that chemical reaction does not take place when copper is added to iron sulfate solution. These are repeated questions. We already discussed these questions. These are repeated questions. We already discussed these questions. So see, in solid state, ionic compounds do not conduct electricity because movement of ions in the solid state not possible due to their rigid structure. In molten state, ions move freely. They carry electricity from one end to another, and that's why they conduct electricity. Then a reactivity of copper is less than that of iron. That's why copper not displaces the iron. Then another one give reason. They asked, copper loses its brown layer gradually when exposed to air. Okay, copper reacts with a moist carbon dioxide in the air and slowly loses its shiny brown surface and gains a green coat. Okay, it's copper carbonate. The next, aluminium oxide is called as amphoteric oxide because it behaves like acid also and base also. It with both acid and base it reacts, and it gives a salt and water. It is a dual in nature. That's why amphoteric. Then June 2019. Write a balanced chemical equation for the reaction taking place when aluminium reacts with a dilute hydrochloric acid. And second question, hydrogen gas is not liberated when metal reacts with a concentrated nitric acid. Give reasons they asked. Okay, aluminium reacts with a dilute hydrochloric acid. Aluminium Al hydrochloric acid. What it gives? Aluminium chloride AlCl3 with liberation of a hydrogen gas. Okay, to make a balance, AlCl3 here chlorine 3 are there. Then to make a balance, what we have to do, we have to take here 6. Okay, then if we take it to here 6 here, then here 2, and to make the balance of 6 hydrogens, here we took 3. Okay, and to balance here aluminium chloride we took 2. That's why here also we took 2. Okay, simple way of balancing explained in separate video. Nitric acid is a strong oxidizing agent. It oxidizes hydrogen produced to water and itself gets reduced to any of the nitrogen oxide. It may be nitrogen monoxide, nitrous oxide, or nitrogen dioxide. Shows the formation of what sodium chloride and magnesium chloride with the help of a electron dot structure, they asked here. Okay, sodium donates one electron. See here, sodium in its outermost whatever the electron is there, okay, that is ready to set free. Okay, that electron donated to outermost orbit of the chlorine, because in chlorine atom 7 electrons are there. Okay, one is electron required. This one is donated by which one? Sodium outermost orbit. And what it gives? It gives a sodium chloride ion. Sodium chloride ion, like this. Sodium chloride. Okay, in between sodium and chlorine, what ionic bond is present? That's why it is an ionic compound. So in the same way, magnesium atomic number 12, in its outermost orbit 2 electrons are there. Those 2 electrons are what set to free. So those 2 electrons are donated to which one? Chlorine's outermost orbit. Okay, chlorine's outermost orbit, always chlorine requires a 1 electron to get octet state. That's why 1 electron from magnesium and another one chlorine gets another 1 electron from magnesium, and those both chlorine reacts with the magnesium, and what they give? They give a MgCl2. MgCl2. Okay, here also exchange of ions occurred, that's why it is also ionic bond. That's why sodium chloride and magnesium chloride. Okay, both these are ionic compounds. And how the electrons are shared, I explained for you here. Okay, next one. Explain the formation of sodium chloride. Explain the formation of sodium chloride. Bond formation in sodium chloride, NaCl. NaCl is an ionic solid. The general electronic configurations are 281, chlorine 287. Then Na is an excess of 1 electron. Sodium, that's a metal, okay, is an excess of 1 electron to attain a octet configuration. Chlorine has a 1 electron less to attain octet configuration. So the excess 1 electron is transferred to the chlorine atom from a sodium atom, and thus the ionic bond is formed due to the transfer of electrons. Then a chloride being a mole electronegative atom, then sodium tends to attract the shared electron pair towards itself. Thus the sodium chloride has Na plus Cl minus atoms. Okay, then chloride attains a octet configuration by gaining 1 electron. Sodium attains octet configuration by losing 1 electron. Thus the ionic solid sodium chloride is a stable. It's a what? Stable. Now we are going to discuss about 4 mark questions related to metals and non-metals chapter. Write the balanced what equation of the following. Magnesium burns in air. When magnesium Mg, okay, when magnesium burns in air, it reacts with oxygen, and what it gives? It gives a magnesium oxide. What it gives? It gives a magnesium oxide. To balance this equation, we take here 2, because here 2 oxygen atoms are there. If you take here 2, then here also it's needed what? 2. Here also needed what? 2. The next one, iron reacts with a steam. Iron reacts with a steam. Iron, okay, it's a steam. Whenever it reacts, it gives iron oxide with liberation of hydrogen gas. To balance this equation, okay, Fe3O4, how many irons are there? 3 iron contents are there. That's why here we took a 3. Then to balance a hydrogen, okay, here we took a 3. Here we took a 3. Here we took a 3 means to balance that equation, what oxygens requires 4 here. That's why here also 4 needed. That's why what we have to take here, we took a 4. Then whenever we took a 4 here to balance the oxygen, the hydrogen turns into 8. That's why here also we take a 4 to balance the hydrogen. 8 atoms to LHS to RHS. Then calcium with water. Why does calcium float what? In water? Okay, calcium reacts with the water. Okay, calcium reacts with the water. Okay, see here it's a by mistake they took a plus. By mistake they took a plus 2. It's a we needed here plus. That's why calcium reacts with the water. Ca plus H2O. What it gives? It gives a calcium hydroxide. What it gives? It gives a calcium hydroxide with the liberation of hydrogen gas. With liberation of hydrogen gas, then calcium floats in water because the bubbles of hydrogen has formed stick to the surface of the metals. Okay, these are the three reactions. Okay, balance. How to balance chemical reactions? I made a separate video. ನೀವೆಲ್ಲ ನೋಡಿರ್ತೀರ ಆ ವಿಡಿಯೋನ. ಹೇಗೆ ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡೋದು ವೆರಿ ಈಸಿಯಾಗಿ. ಇಲ್ಲೊಂದು ಸ್ವಲ್ಪ ನಿಮ್ಗೆ ಕಾಂಪ್ಲಿಕೇಟ್ ಅನಿಸ್ಬೋದು, ಯಾಕಂದರೆ ಇದು ಪ್ರಿಂಟೆಡ್ ಫಾರ್ಮೆಟಲ್ಲಿರೋದ್ರಿಂದ. Then next question. A student was given a few grains of magnesium, iron and copper. She put them separately into test tubes. Which of these metals do not displace hydrogen from acid? Okay, copper does not displace hydrogen from acid. Okay, first one. Second one, forms a pale green color compound. Which one forms a pale green color compound? It's a iron forms a pale green compound. Then next, C, will give hydrogen gas with dilute acid. Then will give hydrogen gas with diluted acid. Magnesium gives a hydrogen gas with dilute nitric acid. For example, magnesium gives hydrogen gas with a dilute nitric acid. 1 minute. Okay, here I think a slightly correction need is needed. That's why I paused there. Maybe it's a hydrochloric acid. Magnesium gives a hydrogen gas with a hydrochloric acid. Which one? Hydrochloric acid. Okay, why? Because magnesium Mg plus HCl. Okay, it gives a MgCl2 plus liberation of hydrogen gas. Okay, next. D, will displace it from a solution of its salts by the other metals. Copper will displace it from a solution of its salts by other metals. Okay, then here give reasons question they given. Electric wire covered with a polyvinyl chloride, rubber like a material. These all things already we discussed. Okay, it's a third clip we are going to discuss. That's why these all things, whatever the give reasons, diagram, okay, previous question papers, these all things we already discussed. Okay, these things we already discussed on our previous clips. Thank you so much.